Hello everyone. Today's lecture is Chapter 3, describing data visually. Okay, let's start. So this chapter we will discuss the date. How can we show the data uh, so to easy to see? Actually, the data is the list of piles of numbers. So it is not easy to see the shape of the data. So in this case, we can show the data using some graphs and so the figures, pictures to understand the data easily. So yeah, so in this case, I'm sorry. So let's see the later pointer. So statistics offers many methods that can help organize, so explore and summarize the data, so visually. So in this chapter, we assume that we have n observations. For example, if you have thousands of samples, then n will be thousand. And x1, x2, and so on, and xn is the data. So observe data one by one. So in this case, if we have this amount of data, then first we have to see that where is the center and how the numbers are distributed. That means variability and shape. So we have to see these three important points. So to see them, we will use the graphical method. Okay, so then measurement is what are the units of measurement. So are data integer or continuous and so on. And so we studied this measurement. It is ordinal ratio or something like that. And so numerical, so discrete number, continuous number, and any concerns with the accuracy or sampling methods. Center is the representing data. It is the data in the middle. So data is so spread, so we have to select one data which represent all of the other data. So in this case, we say that it is center. And variability is how much dispersion is there in data and how spread out the data values, and are there any universal values, any so unusual values, I'm sorry. And shape is that so it is skewed or sharply so the thickness is sharp, or so it is flat or binomial, and so on. So this data, we have to see this this property of data, and it make the readers to be easy to understand the data. For example, if we have price earning ratios for 12 months, last 12 months for each stocks. So here is the company name, and here is price and earning ratio. Price and earning ratio is here. So then based on the price and earning ratio, investors may decide to buy some stock or sell some stocks. Okay, so then we have to analyze this data visually, and we have to see that where is the center of this data, and how dispersion they are, and where is the thickness, and so on. So if you have a data, then first thing you have to do to understand data is sorting. It is as a first step, it is helpful to sort the data. So you can reorder this data from the smallest value to largest value. Okay, and so number of observation is so large, then sorted list of the data value is difficult to analyze. Okay, and the simple list of numbers may not reveal very much about the center variability and shapes. Okay. So anyway, to do the sorting, we can use the the Excel. For example, so let me open the file. Wait for a moment, please. So I will open the data. Here it is. So here is the price earning ratio data. So, and here is company name and price and earning ratio and so on. So then here is original data and here is sorted data. Okay. So how can we sort the data? So let me show you. The simple method. We will repeat it, but for just in case. So let me show you briefly how can you obtain the sorted data. So we have data from here to here. So it is the price earning ratio. I'm sorry, from here to here. So let me copy this data for so copy and paste in here. I'm sorry. So copy the data and paste it in the other page. So then here is the price earning ratio. So they are not sorted, so they are not ascending or descending. To obtain the sorted data, it is very easy. Please find, so here. Okay. So in this, please see that, so here you can see the sorting in Excel. So just select like this. So the first menu, sort smallest to largest. Then you have a data who is sorted. Okay, so again, select sort and filter and sort smallest to largest, and that's it. Okay, let me show you again. If you have data, then so please go to here, sort, and smallest to largest selected. So then we obtain the smallest and largest value. So if you would like to sort largest to smallest, then you can do like this. Then you have the smallest to largest. Okay? So let's continue. So we are using the Excel, so you can find Excel in your Stony Brook IT center. So please find the Excel and so enjoy these powerful tools of Excel. The second method to visualize our data is stem and leaf plot. So it is just a plot. Okay. So it is so let's see the example. and show how can we draw the steam and leaf plot. For example, we have 44 sorted price earning ratio. So 7, 9, 10, 10, 10, 11, 11, 11, 10, 10, 10, 10, 11, 11, 11, 12, 13, 13, 13, and so on. So then, so 7 and 9 has only one digit data. So 7 and 9 is here. And 10, 10, 10, 10, 11, 11, and so from 10 to 19, from 10, 10, 10, and 19 has two digits, but they are all start with 1. Okay, so 10, 10, 10, 11, 11, 11, 12, 13, 13, 14, and so on. 16, 17, 18, 19, something like that. So then group it as here. And another group is 20, 20, 21, 21, 22, 23, something like that. These groups are two-digit data which start with 2. And these guys are the two-digit data which start with 3. And they are two-digit data which start with 4, and so on. So it is 5. So then so group it, classify it by these guys and these guys and these guys, the data which has one digit, the data which has start with 1, 2, 3, 4, and 5. In the steam and leaf plot, so you have like this: steam 0, 1, 2, 3, 4, 5. So 0 means that, so this digit start with 0, 7, 0, 9. So that's why the first digit number is 0, okay, and 7, 9. So okay, so this data can be given as steam 0 and 7, 9. The second data, they all start with 1. So then instead, so we need not to repeat 1, 1, 1, 1, 1, 1, 1 many times. So we remove this 1 and write it in here 1, and only show that the second number 0, 0, 0, 0, 1, 1, 1, it is 11, 11, 1, 1, 1, 1, 1, 1, 2, 3, 3, 3, 4, 4, 5, 6, 6. So 4, 4 means that 14, 14, 5 means that 15, and 6, 6, 6, 6, that means 16, 16, 16. So remove 1, and just give the 6, 7, 8, 9 as this price. Okay, and the third line is start with 2, and so the second number is continued in this place, and the first is start with 3, and remaining numbers are here, and start with 4. In this case, we have only one data which start with 4. So here is 4 and 2. It is 42. And 4049, 5059 is 15 and 15, 50 and 59. So 50 and 59. So if you write like this, then we say that this figure, this graph, this table is called steam and leaf plot. Of course, you can give the frequency in the first column. So we have two observation in the first line, so we just say 2. We have 24 observation in the second line, so we just write 24. We have 11 observation which start with 2, so we say 11. Here we have 4 data start with 3, so here is 4, and 1, 1, 2, 2, and sum them up, then we have 44. That is steam and leaf plot. Very easy. So dot plot is a little different from the steam and leaf plot, but it is the basic idea is exactly same. Okay. So yes, so we just let me so show it based on the example. Price and earning ratio has the 44 data. So the minimum value is 7 and maximum value of this data is 49. So 7 is in here and 49 is here. And here is 7. And we don't have 8. So 8 has no data. And we have 9. Shall we see the data again? So 7, 9, 10, 10, 10, 10. Let's go back to the, the plot again. So 7, and here is 9, and here is 10. So we have 4 tens. So 10, 10, 10, 10. 4 tens are here. And let's see the data again. We have 3 11s, 11, 11, 11. So then in that plot, we just say here is the place of 11, 11, 11, 11 three times. And 12, 1, 12. And 13 is repeated 3 times. 13, 13, 13, and so on. So let's see. Here is 13, 13, 13. So in dot plot, we just repeat the data which is appeared many times. And if it has no data, then we just leave it as blank. And if it has only one data observed, then so it is 31. Yeah, we just give the one plot. So two plots, then that means we have two numbers in 37 and so on. So, okay. So, okay, the center value and so on. So using this dot plot, then we can see that where the data are concentrated and where the data are not so, so rarely observed. So here is not many data, but here we can see that many data are concentrated around here. So then we can roughly see the distribution of our data. So that is dot plot. So if we draw the dot plot, so repeat our dot plot as like this, then we can compare that the data distribution between one so data and the other datas. For example, so 150 US cities so prices, so median home prices. So here is the central states median home price are given in here, and Northeast American cities home price are in here, and Southeast states cities home price is here, and the West home prices are here. So in central area cities has very low house price. So it has no expensive guys. So they are all median values. So the average price are low. And northeast place is like this. Here is low price and middle price and high price spread. And southeast price are like this. It is a little bigger than central prices, but still concentrated in here. And West series price, because it has Beverly Hills and many some rich guys are living in West Place, so they have very expensive houses in here, and also it has low price houses. So San Jose has very expensive home price, so it is not easy to live in San Jose without so good salary. So the West cities has this distribution. So look at this dot plot and compare these four dot plots in one figure. Then we can so analyze the status of the house price based on the different location. So central state cities has very low price of stocks, and in West Coast cities has very high price of house. So using this figure, the politicians and government will be so can be helped by this figure when they would like to do some policy, design a policy for the household, then they have to compare this data. And if some policies are so applied for the West Coast cities, then that may not work for the central cities. So we have to consider that different policy for the central cities and West Coast cities because of this different house price distribution. So the dot plot is used for this kind of example. Okay, so once you have a dot plot, then you have to analyze dot plot based on this dot plot. And so when you do some design a policy or political so government so research, you have to consider that difference distribution of house price of the based on the location uh, data. So this kind of data is called cross-sectional data, as you studied in the chapter 1. Anyway, so the important thing is that dot plot can be used for analyze this kind of information. Okay, so but so that plot has a limitation, so it doesn't reveal very much information about the data set shapes when the sample is small. If sample is small, then that plot is not works well, and they become uh, awkward when the sample is large or when you have the decimal data. So if you have decimal data, then so dot plot is not working. So all of the dots are has so repeat only one. So that's why we have to draw the histogram. Histogram. The frequency distributions and the histogram is important. So frequency distribution is that so define the K classes called bin, and the count the number of data which is included in these classes and show how many data are included in this class. So that is frequency table. So then we can obtain the frequency table based on these 5 steps. First, sort data in ascending order. Second, choose the number of bins. And third, set the bin limits. First, put the data values in the appropriate bin. 5, create the table. So number of bins are so given by K, and so sample size is given by N. Okay, so if the number of beans are too many, then it is not good, and number of beans are too large, then that is also not so good. So the frequency table is very sensitive for the number of beans. Okay, so there is a rule to find the number of beans. So Sturgis rule. So based on the rule, if you have a sample with size 16, then appropriate number of beans is 5. If you have sample size 32, then number of beans, so suitable number of beans is 6, and so on. If you have 1024, then the number of beans, suitable number of beans is 11. So the number of beans can be calculated by this equation. So 1 plus 3.3 log, it is the commercial log 10. So log 10 n, so number of samples. So log 10, not exponential log, not natural log, but commercial log. So don't worry about this equation. So many of them do not know this equation. So just understand that so there is some rule named Sturgis, and based on this rule, we can roughly so it is suggestion, not obligation. It is suggestion. So you can accept this number of beans if you want, but you need not to accept this number of beans. So that is just one guideline for the beans. So if your data is so larger than 16 and lower than 32, so your number of data is, for example, 20 or something like that, then your suggested number of beans are 5 or 6, but it is just a suggestion. Okay. Anyway, so when you decide the number of beans, then so you have to decide the bean width. So you have the data, for example. So please imagine that price earning ratio data. So then it has the maximum value was in the price earning ratio. Maximum value was 59 as so 59. And the smallest value was 7, and the price earning ratio number of samples in the price earning ratio data was 44. So our so suggested number of beans would be 6 or 7. So here is maximum value, here is minimum value of our data, and divide by this number of beans k, then we obtain bean width. Okay. So then all the classes has the width size with this number. Okay, and divide. So divide the data. So if you have so data from 7 to 59, so then you divide this real line as so beans like this, first bean, second bean, and third bean, and so on, and like this. So then so bean width will be so 59 minus 7 divided by so 6 over 59 minus 7 divided by 7, whatever you want. So then that is the width of this bean, and so then here is so what is that value? Okay, let me so calculate it. Then 52. So then the width would be 8. So then it can be start with 4 to 12, and 12 to so 12 to 20, and so on. So let's see the figure and explain that one. So look at the, I'm sorry, look at these figures. If we have six beans, then we divide the real line from 0, 10, 20, 30, 40, 50, 60. So then we have 6 beans. Okay. So and price earning ratio is so given by this one. So then let's imagine that we divide. Okay. So let me show you the. For example, we have so 0 and 10 is the first bin, and 10 to 20 is the second bin. So then 7 and 9 is included in the first bin, so we have only two data between 0 and 10 has, so 2, 0 and 10 has two, so samples are included in 0 and 10 class, and so it is actually 0 to 9. And 10 to 19 has how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah. So anyway, so it is 24 samples are included in the second bin. And so 20 to 29 contains how many? 11 samples are included in the third class, and so on. So this table, if we have this table, then we say that it is frequency table. And this table is drawn in here. So the first bin has 2 data, second bin has 24 data, third bin has 11 data, and fourth bin has 6 data, and fifth bin has 1 data, and sixth bin has 2 data. So then it is the class and frequency is given, then we say that this table is frequency table, and our frequency table is changed to the chart, then we say that this chart is called histogram. So if we have only 6 bins, then histogram looks like that based on the data. If we consider that 8 bins, so 0 to 8, 8 to 16, 16 to 24, and so on, then the histogram looks like this. It is the same data, but so graph is different based on the bin size. Okay, number of bins and the width of bins are changed, then the histogram is changed. If we consider that 9 bins and it starts with 6, then the histogram looks like that. It is the same data, but the bin width is 6, then we have a different histogram. Anyway, they are all represent the same data. Okay, so that is histogram. Okay, so then if you have, let me show you, so next time, let me show you how can you obtain the histogram using Excel. So let me show you data. So Yes. Okay. So we don't have enough time. So let me explain you how can we obtain the histogram next video. Okay. So based on the histogram, we can check the shape of the data, modal skewness, outlier, or something like that. So if the histogram has, so the left tail of the histogram is longer than right tail, then we say that the histogram is skewed left. And right tail is longer than left tail, then we say that the data is skewed right. If these two tails are symmetric, then we say that the data is symmetric. Okay? So that is skewness. We can say that skewed right, skewed left, or symmetric. Skewed right, another name of right skewed data is that positively skewed. Positively skewed, then that is skewed right or right skewed data. Negatively skewed means that left skewed. So skewed left data is called negatively skewed. Okay. So then, so usually the business data is, so price data has right skewed. So the stock price are always positive, so it is right skewed. Okay. But financial return data it has left skewed, so that make very different property of the financial data. So financial returns are always left skewed. So that is very important property of finance. And if you have a chance to study with me for the risk management, then you can find the meaning of this sentence. It is very important property of the financial return. Okay. So model means thickness. So if you have two mountains in the one histogram, then we say that it is bimodal, bimodal data, bimodally distributed. If you have only one mountain, one hill, one peak as this figure, then we say that it is unimodal, unimodal data. So unimodal data. Histogram has single model class is unimodal. If you have two models, then it is bimodal data. So model means that model class means that it is histogram bar that is higher than those either side. So this guy is higher than the other. So left of this data is lower than this guy, and right of this data is lower than this guy. So then if the bar is, so the bar is that higher than those either side, then we say that it is model class. If we have only one model class as this figure, then we say that it is unimodal data. If we have two models as this data, then we say that it is bimodal data. If we have three models, then we say that it is multimodal data. So this shape is bimodal and skewed left. This data has bimodal but skewed right. And this data has multimodal but symmetric. So that is model class. Easy. Okay. And outliers are, so outliers are, if you have some data far from the main this main so main class, so then we say that this isolated data is called outlier. Outlier. We will study the more so the accurate definition of outlier in next chapter. So in this case, if you have a histogram like that, then we say that it is uh, they are these isolated datas are called outlier. So if you have this shape, then these two guys are outlier. So right skewed data also have, if you have some isolated data in the far right tails, then we say that it is the outlier. Okay, so we will study the outlier again. So anyway, so visual, if you see these guys, then we say that these data are outlier, which is very unusual. Okay, good. And so frequency polygons are, so yeah, you can just read it. So it is not so important in my lecture, but for just in case, if you study the polygon and ogive, then you can just read it. It is very easy. Okay. So in this chapter, we studied stem and leaf plot and dot plot and frequency distribution, histogram, and Sturge's rule, model class, skewness, and outlier. So in next video, I will explain you how can you obtain the histogram. So the next video will be very short. So using Excel, so I will discuss the histogram, obtain the histogram using Excel in the next video. So this video we just studied the theoretical background of this visualized data. Okay. Thank you very much and see you on next video. Bye.